Hello guys, this is Sivan from group 4. So for this solution, we'll be solving question 738, which is from chapter 7 and question number 38. So I hope you guys will go through this question. I'll directly proceed to the solution. Okay, so first of all, the given details are the diameter equals to 7 meter, the weight equals to 1020 Newton, the velocity equals to 5.5 meter per second, and the scale of model compared to the prototype is 1/12, and the given temperature is 15 degrees Celsius. So according to the given temperature, what we find from the table is the density equals to 1.225 kg per meter cube, and when it's converted in respect to Newton, it's 12.017 Newton per meter cube, and the dynamic viscosity is 1.802 times 10 to the power of negative 5 kg per meter second. Okay, so there's three parts for the solution: part A, part B, part C. So for part A, the aerodynamic drag on the prototype parachute is equal to the total weight. So we can then easily calculate the drag coefficient CD as required by the question. So as the formula for drag coefficient CD equals to FD over 1/2 rho V area. Okay, so when we substitute the values, we have all the values: 1020 over 1/2, 12.017, 5.5, and to calculate the area we use pi d squared over 4. So we get drag coefficient equals to 0.15. So for part B, we must match the model and prototype Reynolds number in order to achieve the dynamic similarity. So the similarity equation is as follows: Reynolds number M equals to rho V L over mu of model, and Reynolds number of prototype equals to rho V L over mu of prototype. So when we solve equation 1 for the unknown wind tunnel speed, where wind tunnel speed is the velocity of the model, we'll have this following equation where velocity of model equals to velocity of prototype, and as we make velocity of model as the subject, we bring all the other things from the other side, from this both sides to this side. So we'll have this equation, and when we simplify all these things, we'll have 5.5 times 1, because the dynamic viscosity for both model and prototype is the same, the density is same, and LP over LM will have 12. Okay, this is the ratio, so we'll have 12, and when we multiply this both, we'll find the wind tunnel speed equals to 66 meter per second. And finally, part C, estimating the aerodynamic drag of the model parachute in the wind tunnel. So guys, as discussed earlier, if the fluid is the same and dynamic similarity between the model and the prototype is achieved, the aerodynamic drag force on the model is the same as that is on the prototype. So we have the aerodynamic drag on the model equals to FDM equals to FDP. So the force of the model is equals to force of the prototype. So we have the aerodynamic drag on model equals to 1020 Newton as stated in the question, 1020 Newton. So we'll have the same thing down here, 1020 Newton. So that's all from me guys for this session. Myself from group 4. Thank you.